All right, so 11A is called spheres. Okay, our last solid. So a sphere is the set of all points in space equidistant from a given point. It's a three-dimensional circle. Okay, so think of spheres being like a basketball or the globe. Okay, something where all the points around it would be equidistant from that center point. There's really only one measurement you're going to get given on a sphere, and it's the radius, radius or diameter, okay? Because there's no such thing as side length. You can't find a side length here, okay? So the radius goes from the center to any edge around that circle. The diameter would cut straight across. There's a chord, so chord just goes end to end anywhere like that, but you won't use the chord for any of the formulas. You'll need the radius. And then when we talked about the very beginning of the chapter, we talked about what happens when we take a plane and we slide it through these objects. If you take a plane and you slide it through the center or the midpoint or the middle point of the sphere, it cuts it into two hemispheres. So think about the globe, right? We talk about the northern, if you've ever heard of it, northern hemisphere, southern hemisphere, eastern, western. That's what happened if you take it and cut it directly in half. And then the circle that's formed, if I were to take that sphere, slice it open it and look at it in the middle, I'd have a circle. And that circle is referred to as the Great Circle. So we have this line that goes around the earth. Do you know what it's called? That goes right around the middle? The equator, right? So if I were to cut right through the equator and open it up, I'd be looking at what's called a great circle, which is the circle formed by cutting it. Okay. So the first equation we need to know for a sphere is the surface area. Again, there's no such difference as a lateral area and a surface area because it's one solid surface. So the surface area for a sphere is 4 pi r squared. So if you want to add this to your cheat sheet, or you want to wait till we're done with the notes, that would probably be a good idea. Do both of them. We're going to learn surface area and volume. Volume is 4/3 pi r cubed. So two changes here. One, I divide the 4 by 3. And the second is instead of squaring the radius, I raise it to the third power. So whatever the radius is, I multiply by itself 3 times. All right, so complete the table for spheres and leave your answers in terms of pi. So sometimes it's going to give you diameter, sometimes it's going to give you radius, area, and sometimes volume. You've got to work one way or the other, okay? So these are problems done in a horizontal row. So if number 1 gives you that the diameter is 12, what would the radius be? 6. And then the area is 4 pi times the radius squared, 4 times pi times 36. Wow, so sloppy. Okay, and then 4 times 36, which is 144 pi. It didn't give me a unit, so this would be in units squared because it's area. And then volume, 4/3 pi r, which is 6 cubed. So 4/3 times pi, and 6 times 6 times 6 is 216. And then I want to reduce this in any way I can. So I'm dividing by 3. Is 216 divisible by 3? How do you check it? Do you know? Add the digits. So 2 plus 1 is 3. 3 plus 6 is 9. Is 9 divisible by 3? Yeah. So I'm going to divide 3 into 216 to make my life a little bit easier. So it goes 72 times. And then I multiply 72 times 4. And it's volume, so it'd be units cubed. All right, you do 2, and then we'll go to 3. All right, so in 2, they give you the radius. So if the radius is 7, what's the diameter? 14. And then the area would be 4 times pi times 7 squared. 4 times pi times 49, which is 196 pi. And again, no units, so this would be units squared. Good so far? Yep. And then the volume, 4/3 pi 7 cubed. So this is 4/3 pi 7 times 7 times 7, which is 343. Good. 343 is not divisible by 3. So now I've got to multiply 343 times 4. 343 times 4, 12, 17, 13. 1372 over 3 times pi units cubed. Raise your hand if you got it all right. Okay, good. All right. Oh, yep.
Can you divide by 3 still?
No, if you can't divide 4 by 3 or 343 by 3, you can't divide. But you can check it. 1 plus 3 is 4. 4 plus 7 is 11. 11 plus 2 is 13. That's not divisible by 3. You don't want to get a decimal or, I mean, you get a mixed number, but you don't have to do it. You don't want to get a decimal because it's not accurate. Okay, the next one, so if I look at the next one, instead of giving me the diameter, the radius, it's giving me the volume. So I want to work backwards here. I want to say that this equals 4/3 pi r cubed. And there's a lot of ways to start this, but what's one way? None of you did it the way I would do it. I would get rid of the 3 first, right? Get rid of the fraction. So if I multiply by 3 on both sides, what happens? It cancels out the fraction. So you could do it in whatever way you just did it. Like divide by 4 is fine, divide by 5 is fine. But for me, getting rid of the fraction makes it simplified a little bit easier. So now I'd get 30, and that decimal's in the wrong place. 32,000 pi equals 4 pi r cubed. Now I could divide by pi and get rid of that. And then I've got 32,000 equals 4 r cubed. Now I've got to divide by 4. R cubed equals 8,000. And then I would cube root. So I'm looking for 3 numbers that when multiplied together give me 8,000. So there's a couple different ways to do it if you don't know it off the top of your head. I could break this down. So this would be 8 and 1,000. 8 is 2 and 4, which is 2 and 2. And 1,000 is 10 times 100, which is 10 times 10. I can even go further, but if you look there, I've got 3 2s, so I can bring a 2 to the outside. And I've got 3 10s, so I can bring a 10 to the outside. So the cube root of 8,000 is 20. All 3 2s come out as 1 because it's a cube root. And all 3 10s come out as 1 because you need that. So if it's a cube root, I need 3 of a single number in order to bring it to the outside of the root.
And then you just multiply?
And then whatever goes on the outside would get, yep, if you bring out more than 1, you multiply them together. So now R is 20. Diameter would be 40. And then area, 4 times pi times 20 squared. 4 times pi times 400. 1,600 pi. Again, no units. This would be units squared. Questions on that one? Okay, so now moving on to number 4. Number 4 gives you area this time is 12 pi. So area's formula is what? 4 pi r squared. So give me one way to start this. Take out the pi, divide by pi. And I can divide by 4 and pi at the same time, but I can do it in separate steps too. This would be 12 equals 4r squared. Divide both sides by 4, and I got r squared is 3, and r equals the square root of 3. So what is 2 times the square root of 3? 2 root 3, okay? I can multiply a number that doesn't have a radical with one that's with. I just don't do it underneath the root. And then volume 4/3 pi root 3 cubed. So what is root 3 times root 3 times the root 3? 3 root 3. So I would get, there's a couple different ways to look at it. Root 3 times root 3 is 3 itself. That times root 3 gives me 3 root 3. Or root 3 times root 3 times root 3 is the square root of 27, which would break down to 9 and 3, 3 and 3. I can bring out a 3. So whichever way you can look at it, that's what you want to do.
So what happens if like the number is 5?
If the number was 5,
Yeah.
like under the root,
Yeah.
I'd get 5 root 5
Oh, okay. It's just the number twice?
times itself, if it's cubed. Yeah.
Or
He said what would happen if it was root 5 times root 5 times root 5. So this would give me 5, and then that would still be root 5. All right, so that's the cube part. So I've got 4/3 times pi times 3 root 3. Simplify it as much as you can. So the 3 goes into the 3. Those cancel out, and I'm going to end up with 4 pi times root 3, or 4 root 3 times pi. You can write it in either way as long as that root does not go over the pi. And this would be units cubed. So just like before, they're not always going to be the prettiest numbers. Doesn't mean they're wrong. Questions on that one? Okay, now we're dealing with variables. So if my radius is r, what's my diameter? 2r. Area would be 4 times pi times r squared, and the r is the r. So it's just 4 pi. R squared. Can't simplify it any further than that. And then the volume, 4/3 pi r cubed. And it doesn't get any further simplified than that. It would stay just that way.
You don't have to write units?
Oh, this would be units squared. Thank you. And this would be units cubed. Mm-hmm.
Why would you put your exponent like on top of?
So only the r is raised to the third power. If you rewrite it as 4/3 pi r cubed, it's the same thing. You can put either answer. You just can't put the parentheses around the 4/3 and the r, because then you're raising all of that to the third power, and the only thing you want raised to the third power is that r. So either one of those is fine. Okay, and then the last one in this chart says that 2r is your radius, which would mean your diameter is what? 4r. This would be 4 times pi times 2r squared, which is 4 times pi, 2r times 2r, which is 4r squared. And I get 16 pi r squared. Questions on that one? And then volume, 4/3 pi 2r cubed. 4/3 times pi, this is 2 times 2 times 2, which is 8, and r times r times r, which is r cubed. Alexis.
Wait, for the other one, the area, you can combine it even though they don't have the same ending?
Yeah, it's all multiplication. So if it was adding, I couldn't, because one had an r and one didn't, one had a pi, one didn't. But when it's multiplication, you can rearrange them in any order. So volume now, I would, if I could, reduce the 3 into the 8, but it doesn't go in evenly, so I'm just going to multiply the 4 times the 8. I get 32 r cubed. Usually pi's at the end, but that order there doesn't really matter. This would be the same thing as 32 pi r cubed over 3. That's really hard to read, sorry. 32 pi. So either of these answers is fine. It's even okay to write like 32 over 3. Stop the fraction, r cubed times pi. That's all the same thing. And this would be, again, units cubed. Alexis.
So why does it still have the root 3?
Why does it still have which one?
The root 3 over the R.
The r, you mean r cubed?
Okay.
So r itself is still cubed. So when I multiply this out up here, this is 2 times 2 times 2, which gives you the 8. And then it's r times r times r, which is r to the third. All right, then the last two questions ask you to compare. So number 7 says compare the areas of the spheres from 5 and 6. So if I look at the areas here, what do you notice when I compare 4 pi r squared to 16 pi r squared? It's like it being raised to the power of 2, right? It's like I took that first area and I squared it, right? So this would have been the first area squared, okay? Something like that. And I'll give you a hint that this leads to similar solids. That's where you're going with this, because that's the next section. And then it said compare the volumes of the next two. So I went from 4/3 pi r cubed to 32/3 pi r cubed. Wait for it. All right. So now if I'm comparing 4/3 pi r cubed to 3/2 pi r cubed over 3, 32 pi r cubed over 3, what happened from my first volume to my second volume? How do I get from 4 to 32? Multiply by 8, or I took that area and I multiplied it by 16, which is the square of 4. Does that make sense? So I'll leave this similar solid. So you're going to see a lot more relationship with similar solids. For these, you're kind of just comparing them, so you can do it on a case-by-case basis. I would have taken the answer that I multiplied the 4 by 4 squared, or I multiplied the 4 by, or no, that wouldn't be 4 squared. That would have been 64. Do we do the math right there? 2 times 2 times 2. Yeah. This would just be multiplied by 8. So again, you'll learn a lot more relationships when we get to the next section. But when you're just comparing these two, from the first one I could have said I multiplied by 4, or I took the area and cubed and squared it. The second one I multiplied the area, or the volume, by 8. Which again, we'll discover some additional relationships when we get to similar solid too. All right, so this one just says the number of square centimeters in the area of a sphere is the same as the number of cubic centimeters in the volume of a sphere. Find the radius of a sphere. So this is a really great standardized test question. Does it give you what r is at all? No. So what do I know about how would I show the number of square centimeters in the area of a sphere? If I didn't know what r was. I would leave r as my variable, right? So the formula for the area would be 4 pi r squared. I don't know what r is. You with me so far? Now what it says, and then how would I show the number of cubic centimeters in the volume of a sphere? 4/3 pi r cubed. What it's saying here is what's true about these two. They equal each other. So what can I do? Set them equal to each other, and then I want to work backwards to solve for r. So what's one thing I could do? Divide by pi, get rid of the pi on both sides. So I get 4r squared equals 4/3 r cubed. Then what? Multiply by 3/4 or 3, good. Either way, you're going to get rid of your denominator, right? So this would be 12r squared equals 4r to the third. And then I could have divided by 4. So you could do it in 2 steps or 1. And I get 3r squared equals r to the third. Now what? I gotta get both r's on the side by itself, right? These are the same variable. So if it's 3 times r squared, how would I get rid of the r squared? Divide both sides by r squared. If there's 1, 2, 3 R's in the top and 2 R's in the bottom, how does that simplify? Just R. So the only way, which is going to be the only way, that the sphere can have the same area and volume is if the radius is 3. Because it kind of goes back, Sophie, if you think about what we talked about yesterday. If I take an extra 3, I'm multiplying by an extra 3, but with volume, I'm dividing by the 3. The only time it's going to work is if those two cancel out. So it kind of works. Like the question came up yesterday, can the base area be the same as the volume in a pyramid, right? The pyramid. And that the only way that's going to happen is if my height is 3, because the height multiplied by that 1/3 is going to cancel it out. So 3 is kind of like your magic. Okay, last one. A solid consists of a hemisphere of a radius of 1 meter on top of a cone with the same radius and a height of 5 meters. Find the volume of the solid. So it kind of would look like an ice cream cone, a perfectly round. No, a hemisphere is half of a sphere, right? So it's like the ice cream scoop on top. And then the bottom's the cone. So what it's giving you is that the radius here is 1 and the height is 5. How would I find the volume of the whole thing? Pi r squared h is going to give me the volume of the bottom, right? The cone. So the cone, so I have to add the volume of the cone to the volume of a half a sphere, right? Because a hemisphere would be half the sphere. So the first thing we're going to find is the volume of the cone. Volume of a cone would be 1/3 pi r squared times the height. So 1/3 pi, the radius was 1, squared, the height is 5. So 1 squared is 1, and I get 5/3 pi for the volume of the cone. Then I want to find the volume of the sphere, and then cut it in half. So the sphere with a radius of 1, again, volume would be 4/3 pi r cubed. R is 1, which means this is still 4/3 pi, because 1 cubed would still be 1. And then I want to cut that in half, so divide it by 2, or multiply this by a half. And 2 goes into 4 twice, so this ends up being 2/3 pi. And then the volume of the whole thing, I'm going to take the volume of the cone, 5/3 times pi, and add to it the volume of the hemisphere, which is 2/3 pi. And I get 7 pi over 3. This time it gave me a unit, which is meters cubed. All right, that wraps up spheres. One more section to go.